Hey, welcome to this new lecture, and here you learn how to detect faces. And we'll be using OpenCV with Python to detect one or more faces from an image. So basically, how does face detection work? Anyway, well, the idea is that someone has created some cascades, which are basically some XML files, such as this one. And this XML file contains the information about the features that an image of a face contains. So we're talking about ratio of the shadows of the eyes and nose and lips, and all these features, these pixel intensity numbers are recorded in this XML file, which has been created by using some images with faces as training samples. So basically you tell your computers, okay, these are all these are faces, and then you use software like OpenCV to create such XML files. So these are called Haar Cascades, and this is a Haar Cascade for a frontal face object. And if you want other objects, you can find them in this link here. So you've got full body, left eye, and lower body, and so on. Alternatively, you can use the resource section of this lecture. You can download a zip file with all the XML Haar Cascades there. But in this lecture, we will be focusing on the frontal face, so we'll be using this cascade to detect faces. The way it works now is that we will load the image in Python, and then we will tell Python that this is a model that you want to look for in the image, and you want to find this model, so the XML model in the image. And what Python will do with the help of OpenCV, it will start to search all the image using a window, and then it will resize the image, so it will decrease the image size, and using the same window it will detect for smaller faces, and so on. We will go through that step by step. So let's write the script that detects faces. Import CV2 is the first thing you want to do. And then the next thing is you want to read the cascade in Python. So let's call the variable face cascade CV2, and we have a method called cascade classifier. So this will create a face cascade object in Python, and all we have to pass here is the path of the Haar Cascade. That's it. And that will create a cascade classifier object. And now you can use this cascade classifier object of the face feature to search for a face in your image. So the next thing you might want to do is to load the image in Python, the image that you want to search for a face. Let's say image equals. So you know that we can load images in Python via the image read method of the OpenCV. And you can just pass the photo.jpg name here. So I'm passing the file path of this image. So I'm not passing any second parameter here. That means I'm reading the image as a color image. However, a good idea is to use grayscale images when searching for a face. So I loaded the image here, but I'll be using the grayscale version of the image when searching for a face in that image. That is thought to produce higher accuracy when searching for faces. Because you may notice that when you have very busy images with lots of features, OpenCV will not be 100% accurate, so you may get faces that OpenCV will miss out, or you may get features that will be classified as faces. Using the grayscale image, though, increases the accuracy. I could go ahead and pass a 0 flag here so that I could read this image as a grayscale, but I'd like to actually keep the original image as a color version, because I want to show the color version at the end, but use the gray image to pass it to the methods that will be searching for the face. So I'll create here a gray image variable, where I'll store the grayscale version of the image. So CV2, and we have a method called CVTColor, and that takes as argument the original image, of course, and a flag. so an argument called cv2 color bgr2 gray. So what this means is that this will convert the BGR image, so blue, green, red bands, it will convert it to a grayscale image. Let's see it. So if you want to quickly show this gray image, if you like, cv2 show gray image there, we give a name for the window, gray, and the image you want to show, and you need to pass the weight key parameter here, let's say 0, so we'll press any key and it will close the window. cv2 destroy all windows. So you learned these methods in the previous lectures. Let me execute this. So this is a grayscale version of the image. And now we will use a method called detect multiscale. And what this method will do, it will search for the Cascade classifier. So it will search for this frontal face XML file in our image, and it will return the coordinates of the face in the image. So for instance, this is the image, and what this method will return is it will find the face and it will say, so it will give you the number of the row and the column of the upper left point of the face. So it will start here, and it will also give you the height of the face and the width of the face. So we get a rectangle, and then we will draw that rectangle in the image. So that's basically, but you'll understand it better. And so we need to create, let's say, a faces object variable where we'll store this x, y, width and height values. So let's quickly grab that. So we need to refer to the Cascade classifier object, which is this one here. And what we want to do this with this object is detect multi-scale, and you want to detect the gray image, and then you want to pass a scale factor in there. You know that when you have lots of parameters and they are too many to fit in a line, after the comma you can just press enter and Python will read your line as it was one single line. So but be sure to just press enter after the comma. And so we have scale factor, and a good value to give for this would be 0.5. Now what does this mean anyway? Well, let's consider this image. What Python will do is that it will start from the original size of the image, and it will search, it will create a window that will search for faces in the image. So search in this area, in this area, in this area. And so once it does that, then by giving a scale factor of 1.05, you're telling Python to decrease the scale by 5% for the next face search. So what Python will do is it will downscale the image by 5%, and it will research for bigger faces in the image. So search again, and then decrease it by 5% again, the image, and search for bigger faces, and so on until it goes to a final size. So that means a smaller value means higher accuracy. If you give, for example, 0.5, Python would decrease the scale by 50%. So it will start from the original size, and then it will go 50% higher, and so you don't get much accuracy with that. The profit with this number is that the script will run quicker, so you'll have less passes to the image for searching for a face. 0.5 is good. Okay, and then you have another parameter called minimum neighbors, and that is usually set to 5. And what this basically is that This tells Python how many neighbors to search around the window. So you may want to experiment with these numbers a little bit and see which gets the better results. But these two are well accepted numbers. So let's do something now. Let's print out faces and see what this is about. So what kind of object this is. And I could also print the type of faces, just like that. So I'll run the script now, and what the script will do, it will read this XML file and it will load the image. It will make the grayscale version of the image, and then it will detect the coordinates of the upper left corner of the face in the image and the width and the height of the rectangle defining the face in the image, and then it will print out the type of the faces, and it will print the faces, the actual faces object. So okay, press any key to exit this. And so faces is a NumPy array, an n-dimensional array object, and it is an array with 4 values. So we have detected our face, and these are the values basically defining the face in the image. So basically what we have here is, so this is 155, which should be the 155th column. So this is the X, so it's the rectangle should start somewhere here in the forehead, and this should be 83. So the row 83, column 155, and then we have the width, which is 382, and the height, which is the same. And so we have a rectangle in the face. Now let's go ahead and draw that rectangle in the face, in the image. So we created the faces array, and then what we want to do is access all these values of this array. To do that, we can use a for loop. So for x, y, width and height in faces, well, image. So we are updating the image object that we have read here, we have loaded here. So we will update it by drawing a rectangle in the image. And again, you need to pass the image object in here, and then you need to pass 4 more arguments. The first argument would be the starting point of the rectangle, so that would be x and y, so these coordinates of the face array. Great. And then the next parameter is another tuple defining the coordinates of the other corner of the image. So we've got the top left corner in here, and we got the lowest right corner in down here. So what that would be is x plus the width and y plus the height. That's it. Yet another parameter, this would be the color that you want to give to this rectangle. So, and that comes as a BGR format. So you want to pass a value for the blue color, so let's say 0 for blue, and let's have a green rectangle, so 255 for green, so we'll have a full green there, and then 0 for red. And you can also pass another parameter, which would be the width of the rectangle, let's say 3. Okay, and once you do that, so once you have updated your image, you may want to show your image window on the screen now. So we use the image show method, but here we have a gray image, so we want to pass the updated image object, and we should be good to go. Save the script, go and try to run it. And my system is not being able to find the face detector.py. Yeah, I've messed up something with the name here, so let me change this. .py, enter. So nothing to do with the script, and let me try again. Great. So I hope this is what you were expecting. So the rectangle starts here and it has a width and a height and it ends up in here. Sometimes though, as you might already know, you may have images that are bigger than your screen resolution. In that case, your image would not fit in your screen on your screen, so what you could do is resize the image before showing it. So let me create a resized variable here, and that would be equal to cv2.resize, and you want to pass the image, so which contains the rectangle there, and you want to resize the image to these two values. So you need to set the resolution of the image here, and as you know, you can just put some values here, let's say 500 by 500, but these values might stretch out your image, so a better solution would be to access the shape of the image, so the resolution of the image, and this should be the width of your image. So you already know this, I explained this, so I'm just going through this quickly, and to make sure you get a good size, you could divide it by 3, and then again image shape, you get the height, which is the first value of the tuple, and divide it by 3 again, and you also want to convert these to integers, because you might get float numbers, and Python will say that it cannot resize an image to float numbers, so that should be okay. And then you want to show the resized image. Quickly testing it. I'm missing a bracket here, so this should be a tuple, all of these, but here I'm not starting it as a tuple. So the bracket here and closes in here. That should work now. Yeah. So this was my picture, but let's try a more challenging picture now. This one here. So we've got two faces which are not very clear. This is not a real frontal face. This guy here, he has his eyes closed and his chin is not visible. And we've also got these two faces here in the newspapers, which, let me open the original image from here, which have basically very low resolution, and I think Python will not be able to detect these two faces. So let me check this. Here's our face detector, and we want to pass the name of the new image file. Save the script and go ahead and run it. So we've got some back to reality here, and as you see, this time Python and OpenCV were able to detect this face, even though it's not in a very frontal position, and obviously it was also able to detect the hand of this guy, so Python reads it as a face. And what you can do in this case is to tweak these values here, so the scale factor and the minimum neighbors. And something you may also be interested to know is the faces array here has two lists in this case. So this is the first phase, the coordinates of the first phase, and then the second phase, which in this case happens to be a hand, but anyway, you get the idea. So probably by maybe using a 1.1 scale, you may be able to get rid of that hand. So yeah, that's it. You can also try out to detect the face of this guy, but I don't think you'll be able to do it. So just that you know that these techniques have limitations. So it's a computer, it's not a human being, so it will always have some downsides in the accuracy. I hope you found this useful though, and I'll see you in the next lecture.